What's up, chemistry? Welcome back to the Dirt Bike Shed. Here we are for round 2 of stoichiometry, and we are going to do something pretty cool. I think you'll like it. Here I have some pure sodium, and I'm going to put it in water. And you probably already know that we're going to have a pretty cool reaction because this pure sodium is an alkali metal, and alkali metals react very strongly with water, right? Now, the first thing I want to do is write down the formula for this chemical reaction. And if you're not sure how to write it down, you can always look on your North Carolina chemistry tables, specifically at the bottom of page 6. Let's swing over here. On the bottom of page 6, you'll see a single replacement reactions. First you'll see synthesis, decomp, single, double, and combustion. Look at this. An active metal replaces H from water. That's going to give you a metal plus water yields a metal hydroxide and hydrogen gas. So let's think about what that means. Here's our metal, sodium, plus water is going to give us the metal hydroxide, so that would be NaOH, and hydrogen gas. All right. Now this is obviously a solid. This is a liquid. It's water. And sodium hydroxide will be aqueous. We know that. We can look it up. It's soluble. Okay. What is the first thing that we need to do right now if we're doing some stoichiometry? What we're going to do is I am going to put this sodium into this water, and I want you to predict how many liters of hydrogen gas it's going to produce. You should know from the first lesson, the first thing that you do before you start stoichiometry is what? That's right, it's balance the chemical reaction. So if we balance this reaction, we'll end up with a 2 here, a 2 here, a 2 here, and a 1. We can check that. 2 sodiums, 4 hydrogens, 4 hydrogens, 2 sodiums, 2 sodiums, 2 oxygens, 2 oxygens. It's done. So that was question number 1. All right. Now we worked problems yesterday where we learned that these numbers right here, they're called coefficients. And the coefficients stand for the number of moles. So if we were reading this problem, we would say 2 moles of sodium, if they reacted with 2 moles of water, would produce 2 moles of sodium hydroxide and 1 mole of hydrogen gas. So yesterday we did problems like, what if we had 3 moles of sodium and all the water we wanted? Well, then we could make 3 moles of sodium hydroxide. Today it's going to be a little bit harder. Today, we don't know how many moles there are there. So we're going to have to convert that. How are we going to convert that? That's right, we're going to weigh it. All right, so we have 0.22 grams of pure sodium on the scale. And question number 2 is, I want you to convert this sodium to moles, 0.22 grams to moles. How many moles is that? Well, here we go. 0.22 grams divided by 58. Nope. It's pure sodium. It's not salt. I'm sorry. 0.22 grams divided by 23 grams, right? Because that's the weight of a mole of sodium, equals, let me get my calculator. You'll see that 0.22 divided by 23 equals 0.00956 moles. So that's going to round up to 0.01 moles, okay? So we have 0.01 moles of sodium. All right? So you know from yesterday's lesson, we'll say 0.01 moles. 0.01 moles is to 2 as we're going to try to predict how many liters of hydrogen gas we're going to produce. So 0.01 is to 2 as x is to 1. And I'm going to ask you that. That's our question number 3 is what number goes here? 0.01 is to 2 as x is to 1. And that's going to be 0.005 moles. Okay? So, if we have 0.22 grams of pure sodium, that really means we have 0.01 moles of sodium. 0.01 is to 2 as 0.005 is to 1. So if we do this chemical reaction, then we're going to be making 0.005 moles of hydrogen gas. Now here's the question. How many liters is that? So number 4, I'm going to ask you right now, 0.005 moles, okay, of hydrogen gas is how many liters of hydrogen gas? Okay, I hope you answered that one correctly. We would say 0.005 times 22.4 liters. And that's going to give us, take my calculator right here, that's going to give us 0.005 times 22.4 equals 0.112 liters of hydrogen gas will be produced. So we can actually do this. We can take 0.22 grams of sodium, and notice I haven't mentioned the water. That's because I've got plenty of water, okay? That's got an old formula on it. It's because I have plenty of water. I've got an unlimited amount of water. So this is not even important. I have so much water that it doesn't matter. So 0.01 moles of sodium with all the water I need, I'm going to end up producing 0.005 moles of hydrogen gas. So that would be 0.005 moles of hydrogen gas would be 0.112 liters. That's what stoichiometry is. Let's try this. Okay, got my trusty special chemistry lab needle nose pliers. I'm going to gently grab this sodium. Not as easy as it looks. Got to be very gentle. Sodium is very, very soft. And we're going to plop it into the water. And I don't know if you can see that. See the hydrogen gas? Well, that's actually water vapor with the hydrogen gas. So the sodium is reacting with the water. You are literally seeing this equation play out in front of you. And if we let this keep going on and on and on, and I'm getting the smell of hydrogen gas in here, if we let this keep going on and on and on, I'm going to be producing 0.112 liters of hydrogen gas. We got a little flame there. I like that. All right. Well, I hope you enjoyed that. And we'll have a little worksheet.